In this problem on electric force, we're given that a small cork with an excess charge of positive 6 microcoulombs is placed 0.12 meters from another cork which carries a charge of negative 4.3 microcoulombs. First part asks, what is the magnitude of the electric force between the corks? And the second question asks, how many excess electrons are on the negative cork? So I'll start with a diagram. So here I have one cork, and here I have another one. And we have that they are a distance of 0.12 meters from each other. We have that the charge of the first object is positive 6 microcoulombs, and the charge of the second object is negative 4.3 microcoulombs. And we were asked to find for letter A what the electric force is. Our equation for electric force is Coulomb's constant times the charge of the first times the charge of the second, all divided by the distance between them squared. What we have to be careful about, though, is we have to be careful about our units. And so Coulomb's constant is 8.99 times 10 to the 9th. And that's going to be a Newton times meter squared per Coulomb squared. And then we have times charge 1. Charge 1 is 6 times 10 to the negative 6. Again, we have to convert that to regular coulombs. I'm going to use this notation of E, which simply means times 10 to the, and this negative 6 is my exponent. So it'll be a little bit of an abbreviation here. And that's times the second charge, negative 4.3 times 10 to the negative 6. All divided by my distance. And the distance between them is 0.12 meters. Don't forget that that distance is squared. A very common mistake is to not square that distance. So we solve for the electric force, and we get that the electric force is negative 16.1 newtons. Now, what does the negative mean in this answer? It does not mean a direction. Instead, the negative means that they attract. Because they are opposite charges, we get a negative number. So it's not helpful at all in terms of direction, and so from now on, what I would recommend is leaving out the negatives when writing down your charges in the problem. Just keep everything as positive. We'll figure out directions another way. The negative answer is not a direction, and so what I found is causes more confusion than it does any benefits. So besides it asks for the magnitude, which is simply the absolute value of the number. So 16.1 newtons. Letter B asks, how many excess electrons are on the negative cork? So we have that one electron. So one electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. But we have a total charge of negative 4.3 times 10 to the negative 6 coulombs. So the question is, how many of these electrons will it take added together to equal this amount, negative 4.3 times 10 to the negative 6? So how many of these does it take added together to equal negative 4.3 times 10 to the negative 6? If I call n my number of electrons, the way that I would solve for this is I would say that the number of electrons is simply the ratio of the total charge to the charge of just one. And so we have negative 4.3 times 10 to the negative 6 coulombs divided by negative 1.6 times 10 to the negative 19 coulombs. And we get that the number of electrons it would take to equal that total charge is 2.7 times 10 to the 13th electrons. So again, just to review here, we have our Coulomb's law, our equation to solve for electric force. I would leave out any negatives in our charges. They're not helpful. They simply mean that they attract or repel, does not give a direction. And so we get an absolute value here for electric force. And then to solve for the number of electrons, we simply divide the total charge by the charge of just one electron.